One of the interesting things about Coulomb's law is its analogy to gravitation. So suppose we have two objects, Q1 and Q2, and we introduce the unit vector r hat 1, 2, and our distance r1, 2 between these two objects. And the force on object 2 was a constant k, Q1, Q2, over r1, 2 squared, r hat 1, 2. Now, one of the interesting things here is that both the like charges repel and opposite charges attract are built into this law because Q1 can be either positive or Q1 can be negative. Charges can be both positive and negative, the electron negative, proton positive, likewise with charge 2. And so we can handle all of those cases with a sign built into this discussion, into this expression. Now, let's look at the analogy with gravitation. If we have two masses, m1 and m2, remember, mass, as far as we know, can only be positive. And so if we introduce exactly the same notation, r1, 2 is the distance between these two charges, then let's write this as the electric force, the gravitational force on object 2 due to the interaction between objects 1 and 2. Now we need a minus sign, g m1 m2 over r1, 2 squared, r hat 1, 2. And remember, g is the universal gravitational constant. Now notice, because m1 and m2 are always positive, that this quantity in front of the r hat 1, 2 is always negative, and therefore the direction of the force is attractive. And by Newton's third law, we also already know that the force, so between mass, the interaction is always attractive. Whereas between charge, depending on the sign of the charges, and let's just take the case where you have like charges, then the quantity in front of the r hat 1, 2 is a positive quantity, and that means that the electric force is pointing away from the two charges, and that shows that like charges repel. And so this is a fundamental difference between gravitation and the electrostatic interaction, is that here the force can be both attractive and a repulsive force, whereas the gravitational force is always attractive. And this extra minus sign that doesn't appear here, if we just put a plus, many of the similar terms that we describe in terms of potential energy will differ in signs just precisely for this reason.